Begin by inserting a 100 ohm resistor into the breadboard. Next, insert two jumper wires into the breadboard. Connect one leg of the resistor to the negative terminal of 3.7-volt battery we will use in this project using these two jumper wires. Insert a 100 ohm resistor into the breadboard, ensuring it is securely seated with its legs spanning two different rows. Next, insert two jumper wires into the breadboard to create a connection pathway for the positive terminal of a 3.7-volt battery. This setup will allow the power from the battery to flow seamlessly through the circuit, enabling proper functionality. After that, carefully insert two LEDs into the breadboard, ensuring their legs, pins, are correctly aligned. Connect the negative pins, cathodes, of both LEDs to the 100 ohm resistor, which acts as a current limiter to protect the LEDs. Next, insert the IR transmitter and IR receiver into the breadboard. Connect the negative pin of the IR transmitter to the same resistor, ensuring a shared ground connection. Similarly, connect the positive pin of the IR receiver to the resistor to complete the circuit. This configuration will allow the IR transmitter to emit an infrared beam while the receiver detects any interruption. Finally, connect a 3.7-volt battery to the circuit by attaching the positive and negative terminals to the appropriate connections on the breadboard. Once powered, both LEDs should light up, indicating the circuit is functioning correctly. Now, to test the setup, bring an obstacle between the IR transmitter and IR receiver. When the beam is interrupted, you'll notice that both LEDs will turn off, showcasing how the circuit detects the presence of an object. This simple yet effective design demonstrates the principles of infrared sensing and is perfect for DIY and learning projects. To create an air-powered DIY minicar, you'll need a 9-volt battery and a DC motor. Begin by securing the DC motor onto the 9-volt battery using double-sided tape. Ensure the motor is firmly attached and aligned properly for smooth operation. This setup forms the base of your minicar, combining power and propulsion in a compact design. The next step is to solder a 9-volt battery connector to the DC motor. Carefully connect the positive and negative wires of the connector to the corresponding terminals of the motor. Ensure the solder joints are secure and clean to maintain a reliable electrical connection. This step will enable the battery to power the motor effectively, driving your DIY minicar. Next, you'll need to attach two small pieces of plastic straw to the battery. Cut the straws to a length equal to the width of the 9-volt battery, ensuring they are just wide enough to serve as axles for your minicar. Securely paste these straw pieces onto the underside of the battery using a hot glue gun. Once the straws are in place, insert two toothpicks through the straws, ensuring they fit snugly and rotate freely. These toothpicks will act as axles for the wheels. Attach 4 small wheels to the ends of the toothpicks, 2 on each axle. You can use lightweight wheels from toy cars or craft your own from materials like bottle caps or cardboard. Finally, attach the propeller to the shaft of the DC motor. Make sure the propeller is securely fixed and spins freely when the motor is powered. This propeller will generate the thrust needed to move your minicar forward. Now your air-powered minicar is ready. Simply connect the 9-volt battery connector to the battery terminals, and the DC motor will start spinning the propeller. The airflow generated by the spinning propeller will propel your DIY minicar forward. Enjoy watching your creative project in action, powered entirely by air and your ingenuity. Hi friends, today I'm excited to show you how to accurately measure the values of resistors using a multimeter. Here I have a few resistors of different types and ratings. I'll demonstrate step by step how to use a digital multimeter to check their resistance values. We'll set the multimeter to the resistance ohm mode, connect the probes to the resistor terminals, and observe the readings displayed on the screen. Let's dive in and explore how easy and useful this process is. This resistor has a measured value of 148 kiloohms, which is very close to its nominal value of 150 kiloohms. This slight difference is due to the resistor's tolerance, which specifies the allowable deviation from its labeled value. For example, if this resistor has a tolerance of plus or minus 5%, its actual resistance can range from 142.5 kiloohms to 157.5 kiloohms, and 148 kiloohms falls well within this range. Such variations are normal and acceptable in electronic components. This resistor has a value of 120 ohms, meaning it provides a resistance of 120 ohms to the flow of electrical current in a circuit. Resistors like this are commonly used to control current, divide voltage, or protect sensitive components. The 120 ohm rating indicates its nominal value, and depending on its tolerance, the actual measured resistance may vary slightly while still performing effectively within its specified range. Resistors are essential components in electronic circuits, and knowing their resistance values is crucial for designing and troubleshooting circuits. If you want to buy resistors or this digital multimeter online, the links are in the description. Thanks for watching. Today I'm excited to show you how to create a compact and practical emergency torch. This small but powerful torch is perfect for use in the dark during power outages or for any unexpected situations. It's a simple and quick DIY project that's both handy and reliable. To begin making this emergency torch, you will need a coin battery holder. The holder has straight positive and negative pins, which need to be adjusted for this project. Carefully bend these pins into a 90-degree position to make them more accessible and better suited for connecting the other components. This is a small switch that I'll be using for the torch. However, its pins are slightly longer than needed, so I will carefully trim them down to the appropriate length to ensure a compact and neat fit for the circuit. Next, I will carefully attach the small switch to the battery holder using a hot glue gun. The hot glue will provide a strong and durable bond, ensuring that the switch remains securely in place during use. Positioning the switch correctly is essential to maintain a neat, compact design for our mini torch while also ensuring functionality. Now, I will solder the switch to the negative terminal of the battery holder. This step is crucial as it establishes the electrical connection necessary for the circuit to function properly. At last, I will solder the LED to the switch and the battery holder. However, before doing so, I'll need to trim the LED pins slightly as they are a bit long. Once trimmed, first I'll solder the negative pin of the LED to the switch, making sure the connection is solid and free of excess solder. Next, I'll solder the positive pin of the LED to the positive terminal of the battery holder. It's important to double-check the alignment of all connections to avoid any issues later. With this step completed, the core circuit of our torch is now ready for testing. Now it's time to test our torch. I'll insert a 3-volt battery into the holder, and let's see how it works. Wow, it's working perfectly and shining brightly, just as planned. This compact torch is perfect for emergencies in the dark. If you enjoyed this project, please like the video and share it with your friends. Your support means a lot. Thanks for watching, and I'll see you in the next DIY project. Here are 2 supercapacitors, each rated at 2.7 volts and 10 farads. I've soldered them in series, and I'll be using them to power a 12-volt DC motor. First, I'll check the voltage of the capacitors. It's currently 3.2 volts. Next, I'll proceed to discharge the capacitors completely to ensure they are fully drained of any residual energy. This step is important to reset their charge levels before recharging them for the next phase of the experiment. After discharging, I check the voltage again, and it's about 100 millivolts, indicating they're fully discharged. Now I'll begin charging the capacitors by connecting them to a 9-volt battery for a few seconds. This process will allow the capacitors to store energy, preparing them to power the 12-volt DC motor. Checking the voltage again, it's now approximately 5 volts. It's time to connect the 12-volt DC motor and test how long these supercapacitors can run it. Please note the runtime and share your observations in the comment section. While you're noting the runtime, let me share some important facts and insights about supercapacitors. Supercapacitors, also known as ultracapacitors, are advanced energy storage devices that stand out for their ability to store and release energy extremely quickly. Unlike batteries, which store energy through chemical reactions, supercapacitors rely on electrostatic charges. This fundamental difference allows them to perform rapid charge and discharge cycles, making them ideal for applications requiring bursts of energy or frequent cycling. One of the most impressive features of supercapacitors is their high power density. They excel at delivering a substantial amount of energy in a very short time, which is why they're commonly used in applications such as starting motors or powering devices during brief outages. While their energy density is lower than that of batteries, meaning they store less total energy, their ability to provide quick energy makes them invaluable in specific scenarios. Another notable advantage is their rapid charging and discharging capabilities. Supercapacitors can be charged in seconds or minutes, compared to batteries that often require hours to reach full charge. This makes them particularly useful in systems where downtime must be minimized, such as regenerative braking in vehicles or energy buffering in renewable energy systems. Supercapacitors also boast an exceptionally long lifespan. Unlike traditional batteries, which degrade over time, number of charge-discharge cycles, supercapacitors can handle hundreds to even millions of cycles without significant loss in performance. Makes them a cost-effective choice for long-term use, especially in industrial and automotive applications. One area where supercapacitors shine is their ability to operate effectively across a wide range of temperatures. They can function in environments ranging from -40 degrees Celsius to 70 degrees Celsius, making them suitable for harsh conditions where batteries might struggle. This feature is particularly valuable in applications like outdoor equipment, automotive systems, and aerospace technologies, where environmental conditions can be extreme. Supercapacitors are used in various fields and applications. In automotive systems, they support regenerative braking, provide energy for start-stop systems, and improve efficiency in hybrid and electric vehicles. In renewable energy, they help stabilize power output from solar panels and wind turbines by smoothing energy fluctuations. Additionally, they are found in consumer electronics, providing backup power for devices such as memory systems, cameras, and audio equipment. When compared to traditional batteries, supercapacitors offer several advantages. They charge faster, have a much longer, and are generally more reliable due to their design that avoids chemical wear. They're also more environmentally friendly and toxic materials like lead or cadmium. However, their lower energy density means applications requiring long periods, such as power extended distances. In industrial applications, supercapacitors play a critical role, provide emergency power for systems like elevators, cranes, and robotics, ensuring operations can continue during brief power interruptions. Additionally, they help in load balancing and energy storage for renewable energy systems, where they can quickly supply or absorb power as needed. Despite their limitations, the potential of supercapacitors is significant. Supercapacitors to play a more prominent role in energy storage, complementing batteries in hybrid systems, or even replacing them in specific use cases. Supercapacitors are a remarkable technology that brings a combination of high power density, rapid cycling, durability, and environmental resilience, makes them a versatile and innovate. Supercapacitors will undoubtedly become an even more integral part of our energy infrastructure. I hope you've noted the runtime of the motor. Please feel free to share. I also hope you found this video informative and gained some valuable insights about Thank you for watching, and don't forget to like and share. Your thoughts. Get a free Hall effect sensor for DIY projects. Save money by recycling components. Look for an old or non-working 12-volt DC exhaust fan systems mechanism. Next, be cautious to avoid damaging the internal components. Inside the fan, you'll find a small PCB. On the PCB, locate the Hall effect sensor, a rectangular component with 3 or 4 pins. Using a soldering iron, carefully unsolder the sensor from the PCB. Take your time to avoid overheating or damaging the component. Congratulations! You now have a free Hall effect sensor ready for use in your electronics projects, such as magnetic field detection, motor controllers, or robotics. If you're unsure how to use the Hall effect sensor, stay tuned for more videos where I'll show you some exciting project ideas. This is a supercapacitor with a rating of 10 farads and 2.7 volts. A glimpse into the future of batteries and advanced energy storage technology. You can easily purchase it online. The link is provided in the description. Today, I'm conducting a unique experiment with this innovative device. I'll be using